Hello everyone. So in this video I'm going to briefly walk you through the PPT of the transaction model project. So these are the things that I'm going to explain in this particular video. So first I'm going to explain you the aims and objective, followed by the problem statement, and then existing system and its drawbacks, the proposed system and its advantages, project architecture diagram, use case diagram, and modules breakdown. So coming to the aim and objective, right? Aim happens to be one line description of what are we trying to achieve. Objective is nothing but the detailed description of how we are actually achieving that aim. So aim happens to be for managing the transactions in NoSQL system. Transaction, as the name itself indicates, you would be knowing that executing a sequence, a series of queries one after the other, and is called as a transaction. Okay, and objective in this particular project happens to be two things. First thing is to develop and design a prototype application using CouchDB. The meaning of prototype application is a sample application. So though the second objective is the most important one, that is implementing the transaction management layer, we need to prove that our transaction management layer will be working fine in the real world systems. So for proving that our management layer will be working fine, we need to integrate that transaction management layer into some example application and prove how it works. That example application is nothing but our prototype application. Okay, so these are the couple of objectives in our project. So and then coming to the problem statement, right? It is well known that in the existing NoSQL system, there is no support for transaction management. Transaction management meaning especially for the consistency and transaction property like atomicity. So there is no support in the built-in systems. For example, assume that there are 10 queries that are supposed to be executed in a transaction. According to the transaction property, if all the 10 queries have been successfully executed, then the transaction has been set to completed. If one of those queries has been failed, the transaction has to be rolled back. Whatever the queries that has been executed till now has to be rolled back in case any of the query fails in between. Okay, but in the existing NoSQL system, we don't have support for rolling back the queries that already been executed. Okay, so this happens to be the problem statement of your project. And the existing system, as we know, we can take any of the NoSQL system as our existing system. So I will be considering CouchDB. So CouchDB will be our existing system. So the drawback of the existing system happens to be the weaker consistency because it doesn't provide any the rollback feature. Because we don't have any rollback feature, we can say it's very poor in transaction management. Okay, the support for transaction management is not at all provided. So the meaning of weaker consistency is because if there are 10 queries in a transaction, if one of those queries fails in between, then it's an invalid state of the transaction that might result in the inconsistency of the entries that are stored in NoSQL. So we call this as weaker consistency. So we can represent the existing system like that. Okay, where you can see towards the left hand side, a client is directly communicating with CouchDB. So you people have to be understanding that the client need not be a human being, I mean an end user. The client can be an application, so which further will be accessed by the end user. Okay, so for example, you are going to access a site called Flipkart. So Flipkart will be using CouchDB. So Flipkart will be our client. So any of the application who uses CouchDB, right, will be our client. Okay, so in this case there will be no consistency at all, and there will be no support for the transaction management. So this is how the existing system looks like. And coming to our proposed system, right, we are going to develop a new layer, okay, so which will provide the transaction management support for the existing CouchDB system. So that means we will provide the ability for the customers for our clients for rolling back the queries if they want. So which is not provided by the existing NoSQL system. Okay, so the advantage of this is obviously the consistency will be provided, because if there are 10 queries in a transaction, and if any queries failed in between, we are going to roll back all the queries that got executed till now. So that will not result in inconsistency of the data stored in NoSQL. Okay, so we will have better consistency. And then obviously because consistency and atomicity has been met, so we can say ACID properties, I mean atypical transaction properties also will be met. So obviously when even though we are introducing a new layer, right, at the same time we will also make sure it will not take much amount of time. So there will be no latency involved in performing any of the read, write, update or transaction operations. So this is how the pictorial representation of for our proposed system looks like. The customer will not directly access CouchDB. So instead they will send all the read, write, update, delete, whatever database request you have to do with respect to CouchDB. All those requests will be sent to our transaction layer. Our transaction layer will further execute those queries against CouchDB and provides the result back to the customer. Okay. So we are going to achieve better consistency, we are going to provide ACID properties support, and obviously we will make sure there are no negative effects on the performance of the system. So coming to the project architecture diagram, right, I can just say that we are going to install CouchDB in our machine, and on top of that CouchDB we are going to develop a layer called a DB connection. Okay, this particular layer called DB connection will be responsible for obtaining and the connection from the CouchDB and closing the connection from the CouchDB when they're required. Okay, so the the programs in the another modules, when they require to open a connection to the CouchDB, they will not directly open it with respect to CouchDB. Instead they are going to send a request to this DB connection layer for opening a connection and get it. For closing the connection, once again they will send a request to this DB connection layer for closing the connection. And then we are going to develop another layer called database layer, so where we will be providing a facility for the end user for creating a new database and viewing the list of all database you have created in CouchDB. And we are going to implement a layer called data model, so where we will allow the user to create their own data model, or also we can you can see the list of all data models you have created. So the meaning of data model is the data structure. Okay, so for example, if our customer belongs to an hospital, they will have a different data model. If our customer belongs to education institution, they will have a different data model. Okay, so hospital customers will have a data model like patient ID, patient name, patient visit date, patient report, patient prescription, like that. And the education institution customers will be having the data model like USN, name, aggregate, age, project, something like that. So we are not going to hard code any of the data model into our project, we are going to generalize it. So we are going to allow the customer themselves to decide which data model they want. And all of these three layers, right, will be communicating to the layer called operations, where we will allow the customers to create a new entry, create a new row, read all the rows they have created, and also update and delete the existing rows, the data from the CouchDB. So basically in the operations layer, they can perform all the possible data operations with respect to CouchDB. Okay, and there comes our transaction layer. So our transaction layer will provide these three exclusive features. Number one, starting the transaction, beginning the transaction. Okay, and after starting the transaction, right, so they will be able to perform any of those data operations that I have just described. Like they can create a new record, delete their record, update, or just read it, something like that. So after doing this sequence of data operations, right, so the transaction started will be either committed or rolled back. So it will be decided by the customer, the client. Okay, so the support for all these things will be implemented using this in this transaction layer. And then obviously we need to maintain a log of each and every action that has been done within the transaction. Okay, so for that purpose we are going to develop one more layer called transaction log. Okay, so and also apart from this, we will also be requiring our MySQL database. Okay, so the reason for having this MySQL database is to store our metadata. So the actual customer's data will be stored in the CouchDB, but for implementing this transaction layer, right, so we need to store some data temporarily within our project. So rather than storing those metadata within the CouchDB, we will be using this MySQL database. Okay, so because CouchDB doesn't belong to us, CouchDB belongs to our customer, so we are not supposed to store any of the metadata in our customer database. So we will have our own database called MySQL database where our metadata can be stored. Apart from that metadata, right, so we can also store the user login and registration information, like who is actually logging into our system and who is actually performing the transaction. All those things also will be stored in this MySQL database. Okay, so this DB communication layer is the one which will implement all the possible database operation with respect to MySQL, like read, write, update and delete, etc. And on top of that, we will have a feature to create an account, editing an account and deleting an account, correspondingly logging into an existing account, logging out from that account, changing the password if they have forgotten, and retrieving the password over his email, like that. So this happens to be the project architecture diagram. So coming to the project use case diagrams, right, so you can see an end user here, okay, will be able to access his account in these many possible ways, like creating an account, deleting an account, editing the profile, logging in, logging out, etc, etc. And this end user will be able to access this DB connection in two ways, like obtaining the database connection and closing the database connection. Okay, so these two things will be communicating with the CouchDB, and he will be able to access the data model in two ways, like creating a new data model and viewing the list of all data models. And then another second use case diagram is the continuation of the same thing. With respect to transaction, you can begin the transaction, you can commit or roll back the transaction. In between, you can perform any number of data operations. And then with respect to operation, you can create the data, read the data, update the data, okay, and also obviously delete the data which is missing here, but it's understood that you can do any of the database operation. And with respect to database, you can either create a new database or view the list of all the databases created by you. So that's how the use case diagram will look like. And module breakdown doesn't have any significance at all, because you people can decide how many modules you want, and it's up to you. So now let's come to the second part of the PPT. So there's about explaining how actually we have implemented this transaction protocol layer. So before I get into the flow diagram of this PPT, right, I want you people to understand some very basic core concept here. Okay, so assume that we have a student data model with three attributes: USN, name and aggregate, and assume that these are the sample entries inserted for this data model. Okay, and assume that as part of the transaction we are supposed to execute some 4 queries sequentially, one after the other, where in the first query we are trying to insert a new student data with USN 24 and name, say for example Suresh, and aggregate say for example 89.43. okay, and in the second query we are trying to delete the USN with 77. Okay, and in the third query we are just trying to read the entries from the student table, and in the fourth query we will try to update the name from Ram to Ramu. Okay, so whose USN is 66. Okay, so assume these are the 4 queries that I have to execute in a transaction. You can see one is the insert query, one is the delete query, one is the read query, and the last one is the update query. Okay, so here we need to understand how actually the rollback will be implemented. Okay, so for example, whenever the user executes query number 1, we will directly execute this query number 1 in our NoSQL database. So it will actually change the content. Okay, so this was our content of the NoSQL database before starting the transaction. Okay, so now let us assume this is the content after completing the transaction. Okay, so for example, in query number 1 we are going to insert a new entry. Okay, so the new entry will get added here: 24 Suresh 89.43. Okay, so we are done executing query number 1. Like that, in the query number 2 we need to delete the USN 77. Okay, so I'll delete this USN 77. So I'll mark this as done. Second query has been done. In third query we just trying to read the entries, right? So read will not make any changes to the data, so read also will be done. So in the fourth query we need to update the name from Ram to Ramu, whose USN is 66. Here is the USN 66. Ram will be updated to Ramu. Okay, so I can mark even query 4 has been done. Okay, you can see this was the the state of the student data before the start of the transaction. So now this is the state of the student data after completing the transaction. Okay, so now if the user wants to commit this transaction, it's very simple. Okay, we'll simply go ahead for the next step, because we don't have to make any other changes for committing it, because it has already committed in the CouchDB. Okay, but if the user now wants to roll back this transaction, okay, so we now have to roll it back to the previous state. Okay, I mean each and every query. Okay, so we need to undo it. Okay, so how actually we will undo each and every query? Okay, so let us see. Okay, so I need to roll back query number 1. Okay, so insert. What is the opposite of insert? Delete. So for rolling back Q1, I will execute a counter query which is to delete this USN with 24. For how will I roll back Q2? So the opposite of delete query is insert query. So for rolling back query 2, I will insert the USN with 77. Okay, and when query 3 is read, so I don't have to execute any counter query for read, because read will not change any student data. Okay, and in query 4 the user Ram has been updated to Ramu. So I need to execute the counter query, the reverse query. Ramu should now again be updated to Ram. So that will be the rollback of Q4. Okay, so for that purpose, so what we need to do, so whenever the user executes each and every query, so the details of that query has to be saved in a session. Okay, so we will save that in a session. Okay, so for example, okay, I will maintain for list. Okay, insert list. Okay, and I'll maintain one more list, delete list, and then update list. Okay, so in the session is nothing but some temporary cache memory like that. Okay, so I have created some 4 list: insert list, delete list, and update list. Okay, so this insert list will contain the details of all the newly inserted rows. Okay, in this transaction you can see newly inserted rows is this and this, right? So I'll just copy this and I'll save it in the insert list. Okay, so like that, all the queries that got deleted during the transaction, right? Okay, I will save that in the delete list. Okay, along with the USN 77 that got deleted, I need to save his name and aggregate also. The entire data I need to save it here like this. Okay, and then here inside the update list. Okay, so this will be saved like this. Okay, so now in the session we have saved these 3 lists, right? Insert list contains the list of all queries which actually inserted the new row. Delete list contains the list of all queries which deleted the existing rows. Update list contains all the queries which updated the existing rows. Okay, so now let us roll back. Okay, I'll just scan through the insert list now. Okay, so how to roll back the insert query? Just delete the USN 24. Okay, so yeah, I'll perform the first operation. I will now delete the I'll just make a copy of it. Okay, so now I'll delete the USN 24. I'll delete the USN 24. Done. So the rollback of the query number 1 done. Rolled back, done. So this is how I roll back the insert query. Okay, how will I roll back the delete query? So insert list is done, completed. So now go to delete list. Okay, so I have deleted the USN 77 now. How will I roll back the delete? Insert that new row 77. Okay, that's all. So I'll just copy this data and I'll insert it like this. Okay, so I can say this rollback done, okay, and the read will not have to be rolled back because it doesn't change any data. Okay, and the fourth query is to update the name Ram to Ramu. So I need to now reverse it. Ramu has to be updated to Ram, whose USN is 66. So I'll scan through the update list. So here I have updated the name from Ram to Ramu. Now I'll reverse it. So I'll go to USN 66. Here it is USN 66. Ramu. I'll update it back to Ram. So I can mark this now. Rolled back, done. Okay, so now you can see. So this was the state of the student data before the start of the transaction. Okay, if these are the queries that got executed during transaction. So if the user have committed the transaction, I don't have to roll back. So this will be the state after committing the transaction. If the user have rolled back the transaction, so I've executed the rollback on each and every query, and this will be the state. So this is the result of rolling back. You can compare this with the original part. They both will be the same. Okay, so this is the core logic behind implementing our consistency and atomicity properties. So this is the core idea. So now if we go through the flow diagram, you will be able to understand. So I will start the algorithm. So and then in the first step, the client, you can see towards the top left I have indicated the entity who performs that operation. The client is going to initiate a new transaction, NoSQL transaction. In short, I call it as NST. Okay, in second step, you can see TPE. TPE indicates transaction processing engine. Okay, transaction processing engine will receive the transaction request and it will generate a new transaction ID. Okay, this transaction ID is required to store that in the log, transaction log. Okay, and in the third step you can see the TL indicates transaction layer. Transaction layer will record the start time. That means at what time the transaction is started. This is also required for the transaction logs. Okay, and then you can see then comes TPE, transaction processing engine. Okay, so it's going to start the session. I told you session is nothing but some duration of time, so which is allocated for a particular transaction. Okay, so after starting the transaction session, the transaction ID will be returned to the session. Okay, and then the client will be performing various data operations. Okay, for each of the data operations will be executed in the NoSQL system by TPE. You can see TPE sends each operation to the NoSQL system. Okay, and also the transaction logs component will be writing the details of each operation in the session. Okay, because I have told you here like this is how it will be written in the session. Okay, if the user have executed the insert query, it will store the details of the insert query in insert list. If the user have executed delete operation, it will store that in the delete list. Okay, like that it will save. Okay, and in the next step we are going to keep on waiting until the user presses the button, either commit or roll back. Okay, until the user presses this button, we will keep on waiting in an infinite loop. If the user haven't pressed anything, we will check if the session expired, because by default if you leave your machine for 30 minutes the session will be expired. Okay, if the session has not expired, you can see we will go back and wait again, go back to the while loop and wait again. Okay, if the session has expired, go and roll the transaction back. Okay, how to roll the transaction back we will see. Okay, now on this particular branch, if the user have issued the command, if the user pressed either commit or rollback button, now we will check if the user request is to commit. Okay, if the user doesn't need to commit, that means a rollback. Okay, I'll tell you what these two arrow marks will be leading for. Okay, these two arrow marks will be leading for rollback. Okay, that is the most important thing. Okay, so that will be shown in the next slide. So if the user presses on commit button, if the user presses on commit button, we will simply save the session. I mean, we will not execute that rollback methodology. Rollback methodology means these things, whatever we have done executing the reverse query, that is called rollback methodology. Okay, you can see if the request type is commit, we will simply save the session. If the request type is not commit, and then if the session has expired, in both the cases we will execute we will execute a rollback methodology. Okay, so you can see after saving the session, we will simply invalidate the session and close. Okay, so you can see the transaction processing engine, after saving the session, I mean after committing the transaction, it will simply close the session and it will go to terminate. Okay, this arrow mark is for terminating the algorithm. Okay, but there are two more arrow marks here which leads to the rollback methodology. Okay, so here it is. So these two arrow mark will be leading to rollback methodology. Okay, so here comes the rollback methodology. So we are going to retrieve all the operations list executed from the transaction logs. Okay, so we were going to read all the operations list. How many types of operations list we have? 3 types: insert list, delete list and update list. All the operations list we are going to read it. After reading all the operations list, we are going to iterate for each of the operations list. Okay, for each of the operation list. If all the operation list has been completed, then go join this arrow mark and terminate the algorithm. If it is not completed, check if that operation is of type insert. Okay, so if that operation is of type insert, what we need to do? We need to execute its reverse query. What is the reverse query of insert? It's delete. So that's all. So if the operation type is insert, we are going to execute the delete operation on the data set. Same way. Okay, so if the operation type is delete, we are going to execute the insert operation on the database data set, because the reverse of delete is insert. Okay, and then if the operation type is update, we simply execute the reverse update on the same data set, and then finally terminate the algorithm. Okay, and save that commit or rollback time in the transaction logs, and then save it, complete the algorithm. That's it.